Hello there. This is a new endeavor from AAA to make physics problems more fun and to equip you with all the different approaches needed. The section name is, as the name is evident, G.O.A.T, Greatest of All Time Physics, where we learn OP solutions for the greatest of all time physics problems. And each of these problems shall be handpicked from the doubts you ask me in the classes, and the first problem I take up is from Silent Star Prateek in Vijayanagar PU1 batch 2325. He has asked an amazing question. It was not in any reference book as such, but it was from our own AAA module, which he had explored. And it is question number 23 from subjective level, exercise 4 or 5, I guess, where it is question number 23, kinematics chapter, G module 1. The interesting thing about this is it is related to the horizontal projection. Take some time, pause, and read the question. Try to understand. Okay. So I hope you have taken the pause and read the question, because without you reading it, you won't get the feel of it. Well, the OP approach for this is all horizontal projection problems, right? This must be very familiar to you, even in boards and CET. If something is thrown horizontally from a height, definitely it will take a parabolic path and hit the ground, right? This can be seen actually as, you know, this particular motion, which you are very familiar with, ground to ground. I had told you n number of times in the classes where you can't apply h equal to u square sine square theta by 2g to this situation, because it is not ground to ground, but instead it's from some point above ground to the ground. So let us make these same. How? Here is where the mind-blowing technique comes. I call the technique as TR technique. What is a TR technique? In kinematics, TR, as I have named it, is a time reversal technique. Time reversal technique. What does this do? Well, instead of seeing this come from a height above ground to the ground, I can equally imagine I can equally imagine the film running backwards, right? Instead of this falling from a height to the ground, I will I will play it in the video format backwards. I can imagine it being thrown from the ground and taking its maximum height over here with the speed, with the speed v, with the speed v. What is the equivalent picture? As I told, the technique is, instead of imagining it like this, okay, I imagine it like that, where this speed will be v. The same picture, I run it backwards imagine it being recorded in a video camera, and I run it backwards. The same thing will be thrown up, and it will have v horizontal velocity in this direction. The height will remain the same, h. Tada! What does this do? It converts this horizontal projection problems to a normal projectile problem, where height of the tower becomes the maximum height. The power of the time reversal technique. Now you can use all projectile motion equations which you have derived in the class. Okay, we have converted this by simply looking back in time, playing the film backwards to this case. Well, how can I apply it to this question? This question using conventional method is extremely laborious and tedious. Let us apply the time reversal technique, something which you can't find anywhere, to solve this question. Well, let us look at the original picture. The original picture is, there is a food package. The food package was dropped from an aircraft, it seems. I should have drawn this. Okay, this is the aircraft. The food package is thrown from it. It will have the same horizontal speed as the, you know, aircraft. So as it would happen with everything, this will reach the ground. It will hit the ground somewhere over here. According to the question, at some instant of time, it is at 780 meters from the ground, and it has traveled a horizontal distance of 1 kilometer or 1,000 meters. At this particular instant, our question freezes, right? The food package is now here, 780 meters above the ground, 1,000 meters it has traveled already. They're asking two things. What is the altitude of the aircraft, H, and what is the speed, horizontal speed with which it is going, H. And how do I convert this to a projectile motion? Let us use the TR technique, the time reversal technique. So what I do is, first of all, I will take a mirror image of this because it's rather inconvenient. If I play the picture backwards, it will be going like that. No? Instead of that, I will take the mirror image. If I take the mirror image, it looks like this. This height is H. Now, after time reversal, this becomes V. And there is some point over here, which is 780. And the distance from the food package, the 780, if I produce this backwards, this thing is 1 kilometer or 1,000 meters. Cool. This is how I have converted this food package problem, a height to ground problem, to ground to height problem, just by reversing time. Now look at the grand picture we have in front of us. I will write it on a bigger scale so that you can appreciate what's going on, right? This is height h. The speed here is v, horizontal. With some unknown speed, it has been projected from the ground. I don't know with what speed it is coming. Let the vertical initial speed be uy. What would be the horizontal speed? As we know, horizontal speed of a projectile never changes. So the horizontal speed here is also v. And what are the points? The points are, this point is 780. It is at what distance? 1,000 meter distance from bus. Now we can literally do anything. And how much time does it? The food package takes in the original picture. The food package takes 6 seconds to reach the ground. So if I reverse it, will the time change? No. In the backward playing picture also, the food package will take the same time to reach over there. So what is the time taken by the projectile to reach this particular point? It is again 6 seconds. Well, how do we approach? I will use only three equations. The first equation is, it is at a height of 780. So 780 equal to the original y component is uy, uyt minus half gt square. Right? Now I'll put t as 6 seconds because at 6 seconds is just 780 meters. So 780 is equal to 6uy minus 5 into 36. So it would be 780 equal to 6uy minus 180. That would give 6uy to be 780 plus 180, which is going to be 780 plus 180 is going to be 960 approx. And from there, I get the value of uy, right? The value of uy is 96 by 6. It is 160 meter per second. So I got to know the vertical component initially was 160 meter per second. Well, hold on. From vertical component alone, can you determine what would be the maximum height reached by the projectile? Yes, we know that h, maximum height, is uy square by 2g. You see, uy is nothing but u sine theta and ux is nothing but u cos theta. Maximum height is u square sine square theta by 2g. But I can also write it like uy square by 2g. So what should be the maximum height? It should be 160 square by 20. Tada! I found out the height, maximum height. But what is maximum height? Remember, we are doing time reversal technique. The maximum height is nothing but the height of the aircraft when it had dropped the food package. So we have found out the altitude. The altitude of the aircraft is h equal to 160 square by 20. Right. Now, the only thing remaining is I need to find the speed of the aircraft. Speed of the aircraft is nothing but this v, horizontal v. How can I find the speed of the aircraft? Now, here is where the third equation comes into the picture. Let me find the time taken by the food package in reverse to go from this point to this point. That is nothing but half of the total time period. Is nothing but u sine theta by g. U sine theta is nothing but uy by g. The uy for us is 160, g is 10, so 16 seconds. It takes 16 seconds for the food package in the reverse to reach the aircraft. 6 seconds is already done here. 6 seconds is already done here. So what should be the time taken by the food package to go in reverse this distance? 16 minus 6, which is 10 seconds. In 10 seconds, the food package travels 1,000 meters horizontally. Now, well, it travels 1,000 meters horizontally, which a constant speed v in how much time? In 10 seconds time. How will I find a constant speed? Constant speed is nothing but the distance traveled x by the time taken to do so. So I arrive at the speed of the aircraft. V to be 100 meter per second. And if I simplify this, it is 160 into 160 by 20. 20 goes with 160 as 8 times. So the altitude with which it reaches is, from which it is dropped is 1,280 meters. You see, with the minimum of hodgepodge, we have arrived at a very wonderful result that any horizontal projection case from a top of a building can be converted to your familiar, your strength ground to that height only if you use time reversal. You imagine as if the ball is going back in time. So if it lands at this point, imagine it being thrown from the same point. So it will reach the same height, same speed in the opposite direction and stuff. So that is it. So here, the food packet, okay, it was dropped from a height of 1,280 meters. And with what speed was it dropped horizontally? 100 meter per second. What were the relations we used? We used S equal to ut plus half at square for the 780 wala thing. Why? Because we know the y coordinate and the time taken. You need to find the initial speed. That is only possible by this. The initial vertical speed determines the height by h equal to ui square by 2g. The maximum height is nothing but the height with which the food packet was thrown. If you have to get a real feel of this, it is how this is happening. So here is the aircraft. Aircraft is throwing the food packet like this, right? Now I imagine ulta in time backward thing. So if I reverse the time, playback, this is what's going to happen. So this turns out to be the maximum height for the reverse time on the projectile. Okay, so this is the OP technique from which you can solve any horizontal projection problems and especially such tedious problems. You refer any solution, in the book or any open sources. No better technique can find than our own TR technique, the time reversal technique, which is used to convert height to ground horizontal projection cases to ground to a certain height where you can use projectile motion equations, you can use trajectory equations, and so on. I hope this section brought you some insight. I'll be back with more GOAT problems, OP solutions to GOAT problems. I sincerely thank Prateek, the silent star from Vijayanagar, once again for this wonderfully post formulated problem which was hidden in the module. Nobody had brought this to my attention before, so all thanks to Prateek. Keep it up, Prateek. Looking forward to more GOAT problems from you. All the very best, kids. Do physics, feel physics, and take care.